Okay, welcome back. So right now we are on Module 3, Topic 3, Lesson 2, the assignment page, which is page 497. I'm going to use it as an instructional page in class. Just to talk very briefly through the journal entry, we really just answered the very same type of question on the previous page when we did the talk the talk. The journal says, describe the similarities and differences between the graphs of equations represented in the form y equals nx and y equals x plus n, where n is any positive rational number and x and y are unknown quantities. That's what we did here. These are the y equals nx, and this is the y equals x plus n. So what we said is that these equations were multiplicative, which we had in graphs C and D. They go up and that every time whatever the x value is, you're multiplying it by whatever that coefficient is, the rate that it went up at 1. And with the ones that have the addition, we called it additive. So you just added a number to the x value each time. Graphs are powerful visual representations of the relationships between quantities. You can use a graph to estimate a solution. And then you can also formally solve equations if you want to get absolute exact values. Okay, so our practice question says a shuttle space suit. It's hard to say. Say that 3 times fast. Go ahead and try it. Including the life support system, weighs about 310 pounds. Oh my. The break in the y-axis represents the values from 0 to 300. So do you see how there's this little squiggly here? Kind of, it almost looks like a sideways little heartbeat. Have you ever seen those on TV, the heart monitors that go up and down? That's what that kind of looks like. That's indicating we're not starting at 0. We're going to jump up here to 310. It says, what does each ordered pair on the line represent? So this says the weight of astronaut without the shuttle suit in pounds and the weight of the astronaut with the shuttle suit in pounds. All right, so what do we think each of those ordered pairs would represent? So basically it's just asking us what are the axes labeled. So what is the x and the y representing? So the x is weight without. That is an abbreviation for without, and you may use it. Without the suit, comma, the y is the weight, and you guessed it, with is just that, with the suit. Write an equation to represent the relationship shown in the graph. So here's where we have to look at what's going on in the graph. So I'm going to make myself a little t-table, a little xy chart. So when x was 30, it looks like this would be 330, 340. Looks like 340. And let's see, it crosses right here. So when x is 60, this looks like 370. Where's another one that crosses exactly? Right here. When x is 90, y is 400. Do we have enough data points to notice a pattern here yet? 120 goes up to, let's see, 430. Okay, it doesn't look like it's going up in a multiplicative way because it doesn't start at 0, so I know it's not proportional. So I'm going to lean towards additive. Are we adding the same thing each time to go from our x to our y? We would be adding 30 plus 310 would get us 340. 60, do we add 310? Oh, we do. 310 plus 90 is 400. Oh, good. So our y we get by taking our X value and adding 310 to it each time. Oh, and does that make sense? A shuttle spacesuit, including the life support system, weighs about 310 pounds. This is where we're asking ourselves, does our answer seem reasonable? So just to kind of draw a little illustration, we have our man, and then we have his spacesuit. Draw a big spacesuit like this. There's no man in it. That's his suit. They tell us his suit is 310 pounds. So every astronaut weighs a different amount. So the man would be our X, whatever amount they weigh. But every spacesuit, shuttle suit is 310 pounds. So that's how we get to our final overall total weight. Hopefully that makes sense. Sometimes you might have to draw a picture. Is our relationship proportional? No. Justifying it, it shows an additive relationship. In this problem situation, do all the points on the line make sense? Okay, so basically it's asking, can our line be continuous or should it be discrete? Should we just have individual dots or do all of the points make sense? Pause while you think about that. Okay, so basically what it's saying is, can a point that doesn't line up exactly on one of these dots, but a point on the line, so let's say, I don't know, here, which would be 70, could that be a point? Could somebody weigh 70 pounds? And could we add the spacesuit to them? Yeah, we can. So yes. And really it's because weight is continuous. Weight can be any, it would have to be a positive number though. We couldn't go into the negative because people can't weigh a negative amount. But it can continue on this way. Can be any, I guess we better say positive rational number. And weight is continuous. Which means it can be any number, even in between whole numbers. So determine the weight of an astronaut without the shuttle suit given the astronaut's weight while wearing the shuttle suit. Okay, so these weights are while they have it on. So how am I going to get to the astronaut's weight? As we just said that their weight with it was equal to their weight plus the 310, the amount of the suit. So this one we would have the 480 is what they weigh with it. We're looking for this right here, their weight plus the 310. So this is one where you guys can probably see pretty easily that we just need to subtract 310 from each side. I'm going to erase my underline under the X so I can show you algebraically how that works. So to isolate the variable, if I subtract 310 from each side, draw my line, that crosses out. I still have the X. Why does that cross out? It's a zero pair. 310 minus 310 gives me 0. I don't need to add plus 0. Subtract on this side. 0 minus 0, 0. 8 minus 1 is 7. 4 minus 3 is 1. So this astronaut weighs 170 pounds. So I guess for each of these, I'm just subtracting 310. So I can just do it like that. 7, 5. This one weighs 157 pounds is our label. I'd have to squeeze that in there. So 520 minus 310, this astronaut would weigh 210 pounds. Okay, I hope that all made sense. Please, if you have questions, reach out and let me know.